This conference will now be recorded.
So last week we were discussing on the IP address or Internet Protocol address. So we had stopped our discussion at this standpoint, or you can say this milestone, right? So now we are going to go ahead with the structure of IP address, and we will deep dive how the IP addresses and what is the structure and how many bit this IPv4. Okay, so this IPv4 address currently follows the IPv4 format. Okay, so IP address what we are following is of IPv4, that means version 4. Okay, and this is made up of 32 bit. Okay, so why 32 bit? Because at that point of time this was the biggest register, isn't it? My register in the sense like this is all related to microprocessor or electronic circuits, where each motherboard will have a some sort of a register wherein we used to assign addresses. Okay, guys, can you go on mute? I see some disturbance, I hear some disturbances, it will disturb the, yeah, thank you. So, and this 32 bit is based on binary. Okay, binary in the sense 2. I'll explain each in detail today. Okay, binary is 2. Now the next concept is, so how it will be 32 bit, because the what you are seeing here separated by a dot, so this is known as a period, and before that you can see one number. Okay, so this number, when you convert into the binary, okay, because in the last class itself I told you the machine will only understand. See, now let me write one IP address. Imagine this is the IP address 1.2.3.4. So this is the IP address of this computer, and similarly this is having another IP address, say 5.6.7.8. So this is another IP addresses. Now when I say this number, this is only for us. The computer will not read it as 1, 2, 3, 4 at the microprocessors level or at the machine level. Okay, so this it will read it as sequence of zeros and ones, like this, like this. So this will read it as this. Okay, while transferring the data, okay, while receiving the data, it will receive as this, and this will be of course converted into a language which is understood by us, and it is displayed. Okay, so now each period is of 8 bytes or 8 bits, you can consider. So I'll write it here. Each bit is of 8 bits, not you can say each period. Okay, so this one, so this is of 8 bits. 2, this is of 8 bits. 3, 8, 8. Similarly 8, 8, 8, 8. So 8 into 4, there are 4 periods, right? 4, 1, 2, 3, 4. So 8 bits into 4 into 4. So that is why we give, we come to the conclusion, I mean we come to 32 bits. Getting the point? Clear? So this is the meaning of 32 bit. Okay, of course now we are having IPv6, that is version 6, which can have a IP address of 128 bits, which is very very huge. But in our class or in our syllabus we are going to cover only IPv4, because we are still, there are company who are quite happy with IPv4, the number of IP addresses, right? So we are not going to go with the IPv6. Okay, we are going to cover only IP version 4. Okay. Now, so now you came to know that 8 into 4, so 8 bits into 4, that is 32 bits. Now how these are organized? Okay, so these are organized from the rightmost bit to the leftmost bit. Okay, in the reverse order. So let me show you one. Yeah, see, like this. So let me maximize this. Okay, so what is an IP address? It is a unique identifier for a computer or a device on a TCP/IP network. Okay, and a 32-bit binary number usually represented as a 4 decimal number separated by a period. This I have already covered. So example is this one. Okay, so last week we also saw that every computer will have a IP address. Only then it will be able to connect to the internet. And see, we will see the IP address in this format 206.40, then 185.73. But the computer or the server or any node or a device will interpret this as this, like this: 11001110 dot 00101000 dot 10111001 dot 01001001. So how this is possible? Okay, now I am saying that each address is of 32 bits wide and valid addresses are from 0.0.0.0 to 255.255.255.25. Why we are stopping at each period? Why it start from 0 and why it stops at 255? Why that is the maximum at each period? Why it can't be 300? Why it can't go beyond 256? Or why it can't go beyond 255? The reason is because the maximum, as I told you, in each period it is of 8 bits and it will start from 2 to the power of 0 in from the right hand side to the left hand side. So 2 power 0, 2 power 1, 2 power 2 up to 2 to the power 7. Okay, so let me add it here. So let me come back. Let me open an Excel to, so now, okay, so 1 2 3 4 5 6 7 8. So here it will start from 2 to the power 0, 2 to the power 1, and similarly, okay, 2 power 2, 2 to the power 3, and 2 power 4, 2 to the power 5, 2 to the power 6, and 2 to the power 7. So this is the story of each period. Okay, now let me write an IP address here. So 192.168.0.101. So this is the example, one of the example of an IP address, right? So isn't it? So now this, each period will have a 8 bits. Now this I am representing one of the period in this format. Okay, so what is 2 power 0? 2 power 0 is 1. What is 2 power 1? It is 2. What is 2 power 2? 4, 8, 16, 32, 64, and 128. You're getting the point. And when you add this, so let me add all this. So let me write a formula to add. So sum, second, sum of all these numbers. Okay, if you do enter, what is the result? I'm getting 255. I'm going to highlight this. Okay, so 255 we are getting the result. So that is the reason in each period 1 2 3 4 no, no number can go beyond 255. Why? This will become 255 only when all the positions or all the bits are true. True in the sense 1 1 1 1 1 1 1 1. Now because computer understands only zeros and 1. So in each field 1 represents true and 0 represents false. If in each of these bits if there is 1, then it will add up to 255. Then if what is the another case, in all the fields it will be 0 0 0 0 0 0, then it will be 0. Getting the point? So this is a 0. So that is why in the previous slide I explained you people that so that is why any valid address, right? So any valid address can range from 0 to 0.0.0.0 to 255.255.255.255. Clear? Now we have with the IPv4 we are close to 4.3 billion IP addresses we have. Why? Because as we are following the binary and the maximum value of the IPv4 is 32, so 2 to the power 32 is 4.3 billion IP addresses. So you can calculate by yourself. If you do 2 power 32 in a calculator, you will get this value. Okay, so that is the meaning of this. Now let me go back to the this thing. Now you can have this for each of the fields. Okay, now before we going to this, what I said, like before we going to the network part and the host part, let us try to understand the each field. Now suppose if there is 192, let us try to understand how the computer will look 192 as. Okay, so let me write here. So 192, so 192 can be written as 1, put 1 here, in put 1 in those places in such a way that if you add that respective value in the row 2, so let me mention here, this is row 2 and this is row number 1. Okay, so in the row 2 equivalent value, if you add, you should get this value. So similarly you should place the number 1 and number 2. Okay, so let me write here, you will understand. For example, I have taken the 192. So 192, 128 plus 64, what is the result? So 130, 132, 192. We got the value. Then remaining fields you put 0. You're getting the point. Similarly, 162, sorry, 168, right? That is address. So 168, you have to put 1 in such a way that the resultant value in this row 2, if you add, you should get the 168. So here I'll put 1. So I cannot use 64 because if I use put again, if I use 1 here, then if I add 128 and 64, I'll get 192. I don't want that. Let us try with the third one. So 128 plus 32, so 160. So you can put here, and then you can put 0 here, and you can put 1 here. So remaining else is 0, 0, 0. So because 128 plus 32, 160, and 168, 160 plus 8 is 168. So this is how you represent 168. And 0, just simply put zeros. That's it. So all the digits it's 0. 0 is 0. Now tell me for 101. It is same thing. So for 101, the last bit, I mean the last period value is 101. So how to, so I cannot use 128. So it's 0. So you can use this 64. Okay, so what is 64 plus 32? So 64 plus 32 is 66, 96. You can use, yes. So 96, right? I cannot use because 90, I mean 16, because 96 plus 16 is 106, 100. So you cannot use. So put 0. Okay. So yeah, 96 plus 8, 104. So I cannot use this 0. Okay. So 96 plus 4 is 100. Yes, I can use this. And 0 and 1. Yes. So now this is for human value, means for us. And how the computer will look it? So let me write it here. So the computer will interpret it as 110000 110000. Okay. So this is the 192. Okay. The next is 168. 1010100. Okay. Then next 00000000. As this is Excel, so this will not take multiple zeros, so you can understand all the zeros, right? And the last one is 011000101. Yes. So this is how the computer will interpret the this digits into the binaries. So this is the meaning of IP address. IP address v4, and this is how you can convert decimal to binary. Okay, clear? Now coming back to this diagram. Now this is saying each address consists of two parts. So one is the host part and the other one is the network address. Okay. Now before we go into that, okay, so initially when the internet was born, people decided to use the IP addresses based on the classes, or commonly also known as the network classes. Okay, so predominantly there are only three classes: class A, class B, class C. You're getting the point. So now let me go back to the Excel sheet here. I'll explain each classes. Okay, now they made rules. So class A, class B, class C. So what does it mean, class A? They made a rule because even though we were having 4.3 billion addresses or 4.3 billion IP addresses, they were having some sort of a restrictions. They wanted to imply some of the restrictions. Hey, look, man, if you want to use our IPv4 structure for your IP addressing need, you need to follow our classes. And if you are using the our IPv4, so when you use these classes, by default there are some rules. So what are the rules? They told to use some ranges. Class A means only this range. Class A, B means this range. Class C means this number range. So what is that number range? So class A means, going back to the, it is 0 to 126. Okay, so 0 to 126. Okay, then class B means 128 to 191. Okay, and class C means 192 to 223. Now you may ask me, there is 0 to 126 and 128 to 191. Where is 127? So 127 is does not belong to any of the classes, because 127.0.0.1 is a special IP addresses known as loopback. loopback IP address. So what does it loopback means? So in any networking devices, there is something known as a network interface card. Please note this point. Okay, I will show it to you. So go to your device manager and you will see in the, now these are called as network adapters, or commonly also known as network interface card. So these are responsible, and this network adapters are responsible for connecting the operating system or our laptop to the internet. If you delete any of this, you will not be able to connect to the internet. Okay, so this loopback IP address is the IP address of that network interface. And if using this IP addresses, you can check whether your network interface is working properly or not. So how to check that? So all of you open, go to search and type for CMD, right? And just type ping 127.0.0.1 and hit enter, and you can see it is getting a response. So this is the loopback IP addresses. It will say it will send 4 packets, and if it will receive 4 packets, this means your network interface is working fine. So that is the reason you take any operating system. Okay, I have also installed Linux in my virtual box. I will show it to you. 1 second, just a second here. Yes, so this is a, now if I do ping 127.0.0.1, so you are getting a response. So this is a Linux machine. Clear? So this is a way to check whether your network interface card is working fine or not. Okay, so that is the reason 127 does not belong to any of the classes. Okay, next point. So let me write here. Okay, so now the first restriction is, or first the first rule says you have to use this range. Then what next? The next restriction or the rule they brought in was, if you are going to use class A, then you need to use the subnet mask as /8 /8. For class B it is /16. The second, yeah, /16, and for class C it is /24. Now you may start to think that what is this subnet mask. Okay, so I'll explain, don't worry. It means that I was telling, right, as per the diagram here, this one, each address consists of two parts, that is network address and the host address. So these two elements is dependent on the this factor /8 /16 /24. So /8 means the first 8 bits. See, we have in every address we have 8 4s are 32, 8 8s 8 8, that is 32 bit. So /8 means the first belongs to the network. Please note this point. So the first period or the first octet. Why octet? Because 8 bits, right? So the first octet belongs to the network. Okay, you're getting the point. That means, okay, so this means first 8 bits belongs to the network address, and the remaining 8, 8, 8, that is 24. So the remaining 24 bits belongs to the host bits. In other words, you can only assign these 1, 2, 3, the last 3 after 192. So only these you can assign to your machines. And this you cannot. This is a unique network ID. You're getting the point. So this means that the first field all will become 1. Okay, so all will become 1. That means it will be 255. So the subnet mask will be /8, which is equal to 255 dot, remaining else is nothing, no? So 255 dot 0 dot 0 dot 0. Clear? Now next, /16, same thing. So /16 means 192 and then 162. So 8 and 8, 16. These two octets belong to the network. Then what is remaining? 32. So the subnet mask will be 255.255, sorry, 255.0.0. Getting the point? And similarly, /24 means 255.255.255.0. Because in the class C, the first three, 192, these three belongs to the network, and the last one belongs to the host. So if this is the case, how many IP addresses we can have with class A, class B, class C? So for that there is a formula. Just so number of IP addresses. Number of IP addresses. Okay. So number of IP addresses. So that means /8, right? Simply minus 8 by 32. So 32 minus 8. How many will get? 24. So we'll get 2 to the power 24 IP address we'll get. We just calculate. Now similarly in this also 16, right? Just subtract from 32 minus 16, right? Which is equal to 16, right? So 2 to the power 16, which is equal to 65535 IP addresses. Sorry, 65536. You can check, cross check. Okay. And this one is the smallest. Again 32 minus 24, which means 8, right? So 2 to the power 8, meaning 256 IP addresses. So this is the, see, these calculation you should know, guys. Okay, so in any interview they may give you this value and you have to tell the number of IP addresses. Just you have to subtract and you will get the value. Clear? Now going back to this, okay. Now see here, this I already covered. Class A begins with 0, class B begins with this one, sorry, 129, right? And so on. Now if you go further, see 192. So class C begins with 192. Class B begins with, actually it is not 120, 128, because 126, 127 does not belong to any of the IP addresses. Okay. So we are not bothered about class D and class E because these are used in special type of networking components. Okay. We are going to only use still the class C. Okay. See here. So this was I was trying to explain. So class A means, so there are 1, 2, 3, 4, 5, 6, 7, 8. So these 8 bits belong to the network and this is your host. Class B, similarly 8, 8, 16 belong to your network and these belong to your host, and similarly class C. So where X is equal to network and Y is equal to node, means you can assign it to your machines. Okay. So see here. So this is the meaning of class A 1 to 126. That means 2 to the power 7, 126 network IDs and 16 million IP addresses. You're getting it? So this is the network ID. Why 2 to the power 7? Because 2 to the power 7 is 126. Okay. That means this is the smallest number. This will have the smallest number of network ID, and this will have the class A will have the largest number of IP addresses. That is 16 million IP addresses. You are getting the point? Any doubt, guys? Okay. So this is the concept of network ID and the host ID. Okay.
Mithun sir, sorry to disturb you.
Yeah, go ahead. Yeah.
Um,
Yes.
can you
Yes, go ahead.
explain can you define the bit? What is bit?
Yes. See, bit is something to store information in the binary format. So it will be in the registers, right? So in the microprocessors, in all motherboard, it is based on the microprocessors. So bit is something to store a valuable information in the form of binaries. That's it. So that is called as bit.
So the calculation, what you have shown, the same thing. So you said a 8 bit. So you have defined into to the power of 0 to 7. Okay. So it
Yeah,
should be calculated in the numerical value of 2 or any kind of number.
yeah. No, in the power of two.
So this is the basic criteria.
Yeah, that is the basic. I told no. So the IPv4 follows the binary format. So binary means two. Binary means two. So any representation, I mean any conversion, you have to do with the power with respect to two only, because that is these are the rules imposed by the IANA. So this is the organization who invented the IP addresses, right? So we have to use this formula only.
Thank you.
Okay, so you cannot use any other number. You have to use either only two. You cannot use three and four other. No, because binary the value representation is two. So that is the reason we are using two here to convert anything. Okay, clear?
Yes.
Okay, now next. Okay, now these are the IP net. So this is the class A. So by looking now you are in a range to tell these are the three IP network address reserved for private network. See 10 0.0.0 slash 8, 172.16.0.0 slash 12. Okay, so these can be used by anyone setting up an internal network. Okay, so these are some of the restriction imposed by the IANA. So if you want to learn more about, right, so let me give you a link on IANA. So now this is an organization. So if you want to learn more about IP addresses, you can follow this link. Okay, I will put it in the group. Okay, so these are the address. Clear? So you can use this reference. Clear, guys? Okay. So we are going to go further. So now if I give you any IP addresses, you are in a position to convert this into this format. I mean this format, right? So now what happened was, even with this bifurcation of classes, people were facing some difficulty. What they were facing? People were facing difficulty in organizing their sources in the that particular address. Okay. Now if I say here, if I go with the class A, now as you can see, now this is class A. Let me maximize for you. Now this is class A. It means /8 I'll get 2 to the power, that is you can say close to 16 million or some IP addresses, right? So that is a very big network actually. That is the biggest number of IP addresses. So if you choose this, so people started facing some of the issues to organize their resources. Okay. And they came to the concept of, okay, so they came to a concept of something known as subnetting. Okay. Okay, what is subnetting? The dividing this big network into smaller networks. Dividing the biggest network into smaller networks. Okay, right? So that is the concept of subnetting. See, can be done for a variety of reasons: organization, use of different physical media, preservation of address space, security. The most common is to control the network traffic. See, I'll give you a best example. So you will buy an almirah, or you will have a wardrobe, right? Or if you go to library, how they have arranged the books in the racks. So there will be small racks, right? So that is how you identify. So this section belongs to this. So these are novels. These are say children's stories. These are medical related section, right? So similarly, in if you have divided into a structured way, only then it will be easier for you to identify one of the books. But if you don't have that classification, if you don't divide that into sub racks and multiple racks, if you dump as it is, so will it be easy? So it will take a lot of time to search for a particular book. So similarly, subnetting is a concept where you divide the big network whatever you have created into smaller chunks, so that you can divide the resources into that particular subnets. So a big network when divided into smaller parts, those are called subnets or subnetworks. And you can control the traffic also. Okay. Now I told, right, Ethernet network. So Ethernet means that is the card. Okay. So at the network level, it is all based on the packets, right? So in the background also you can see zeros and sequence of zeros and ones, right? So at network level, whenever you are sending a message from say node A to node B or source to the destination, it is all based on the packets. So the sender will send the packets and the receiver will receive the packets on the other node. Okay. So when there is no bifurcation of the networks, so there can be some of the performance issues. Okay. See, now this is the main point. The third point, a router is used to connect IP networks to minimize the amount of traffic each segment must receive. So you might have, if you are using a broadband connection, you might have all seen the router. Okay, so router is a device which will connect all the machines at your, or all the devices, whether it can be mobile phone, laptops, desktops, any, or your smart TV. You all connect to the same router, and the same router is used to forward your request to the other destinations or other sources. Okay. So with the help of subnet masking, it will allow you to identify the network, right? If you are divided into, so say one big network is there. So you have divided into four parts. So in that four parts, you can say two are for private and two are for public. So like that you can bifurcate and differentiate. And looking at the subnet ID, you can say this belong to this team or this belong to this resources. So like this, it will be useful with the help of subnet masking. See, so this is the calculation how we got the subnet mask, right? So based on this, so every device will have a subnet mask, you can check. Okay, so I will prove it to you. So now again open the command prompt here. Okay, now if you do ipconfig, now see here what is the subnet mask. 255.255.240.0. Why this is 240? Because we are following a 255. What is this? So as you can see, this does not belong to the any class. So now that is the concept called as CIDR. Please note this point, guys. So this is the concept known as CIDR. So let me go back to the Excel. So CIDR means classless interdomain routing. So what does this mean? So this means that as per this, there is no restriction of the classes. Of course, this subnet mask concept is there. Otherwise, it is very difficult to identify the network and the host part, right? But what they release this in, I mean restriction, that if you are going to use class A, you have to use this subnet mask. No. So classless interdomain routing means you can use any of the subnet mask. It can be 10, 20, 24, 32, or 20, like that. Okay, and please note that as per a cloud computing, okay, the maximum CIDR allowed is, or the maximum subnet mask allowed is /16. So let me write here as per the cloud computing. So maximum /16. That means how much? 65,536 IP addresses. Okay, and minimum /28. That means how many IP addresses? Very simple. 32 minus 28, 4. So 16 IP addresses. So this is the minimum. You cannot have any of the subnets with the greater than 16 or less than 28. Like you cannot have like /29, /16 or something like that. You're getting the point? So as per, so in, when we start building the real time network in the AWS, right, we are going to start with /16 and end with /28. You cannot go beyond these numbers. Okay, so classless interdomain routing means, see, as you can see, /28 does not belong to any of the classes. See, Okay, slash 16 it belongs to class B. I agree. But you can use this with this number range also. Nobody is going to stop you. You can use the number as 10.0.0.0 and slash 16. For example, 10.0.0.0, and as per this you can use slash 8. You should use slash 8 because as per the classes. But with the classless interdomain routing, you can use class B also. You can use class in between, range between class B and class C. You can do that, and you can use slash 28 also. Nobody is going to stop you. Okay, so these are some of the restriction which they removed. Okay, and for 192, so 192.168.0.0, you can use slash 16 or slash 20. Also you can use slash 22, slash 21. So any number you can use. So that is the one restriction they have removed. So this is the concept we are going to continue in cloud computing. We are using classless interdomain routing. We are not no more using classes. No, there is no restriction for us. You can pick up any number you want and you can go ahead. Okay. So now going back to the, okay. So now this is a how to calculate the subnet mask. Okay. I'm going to, this seems to be complex, but I'm going to teach you the easiest way to calculate the subnet mask. See here, they are trying to perform a bitwise logical and between the IP address and the subnet mask result in the network address. Now see here, they have taken an example. I will try to explain. See, they have taken a class B which is of 140.179.240.200. So 140 they will represent like this: 100.1100.100.1 like this. 179 is this, 240 is this, and 200 is this. Okay. Now class B, what is the subnet mask as per the classes? So you have to use slash 16, correct? So slash 16 means all are 1 up to the second octet, means until here. You are getting the point, isn't it? So now performing the logical and operation. So 1 and 1 is 1, 0 and 1 is 0, 0 and 1 is 0, 0 and 1 is 0, 1 1 is 1, 1 1 is 1, isn't it? So this is how the AND operation. So 1 and 1 is true, 0 and 1 is false, 0 and 1 is false, 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 true. So now we'll get this result. Now when you add this, it will get 140.179.100.000.000. So this is how you can calculate the network address. Clear? Anybody having doubts? Guys? Okay. So I'm going to stop it here today. So I'm going to share this with you. So any doubt you can ask me. Let me stop the recording.